All right, welcome everybody. Thanks for joining me today. Today is our first episode of OrbitLIVE. The idea with OrbitLIVE is just once a month, I think, for the time being. We're going to do a live broadcast on a particular topic in AWS. And when we were thinking about what this looked like, originally started going down, the traditional slide path, but I figured that, hey, it might be more fun just to actually get in the console and kind of work through some concepts. So that's what we're going to try. I've got my little cheat sheet here of the topics I want to cover. I scheduled this for about an hour. We'll see how long it takes to get through all the topics, but yeah, let's just jump right in. So today we're going to talk about identity and access management. These are meant to kind of be introductory level type courses. So we're not going to go super deep into any of the topics. The idea is to kind of cover off at a high level some key areas of the various services that we're going to review. So let's just jump right in and talk a little bit about identity and access management. I'm in our demo account, so you'll notice a few things already have been set up here. But I thought today we would kind of hit on some core topics I think are important from a security perspective in identity and access management. We're really just going to work down the left-hand sidebar here and talk about all the different entities that you can create. We'll set some things up and things like that. The first thing, though, I do want to talk about is the root user. And the root user you can't see here, but if you're not familiar, the root user is the email and password combination that you use to create your account. And the thing that's really important to remember about the root user is it's not meant to be used for day-to-day administration or management tasks within your AWS account. It's really meant to be used for, less than a couple of handfuls of actual activities. So once you've created your account, one of the very first things you should do is obviously you want a very secure password on that root user, and you want to secure that root user with a multi-factor authentication device. Something is your password, something you have is your token. The decision on the type of token to use is completely up to you. AWS supports a number of different options, like physical tokens, like the fobs, credit cards. In my case, the root account will use in our demo account. I'm using a little YubiKey that I've got in the side of my computer here. You could even use like a software or a soft token in, say, a password vault or something like that. The other thing to keep in mind with the root user is, unlike what I'm going to show you today, in a single AWS account, a root user is not controllable through permissions, right? So that means the root user can do whatever they like in the account, including closing the account. So that's another reason why you really want to make sure that you're properly protecting that root user and you're only using it when absolutely necessary. So that's the first topic I wanted to discuss. When I say about not being able to control a root user in an individual AWS account, there is an exception to that. And the way that you can control a root user is with the AWS Organizations service. And within that service, member accounts of your organization can have service control policies, SCPs, applied to them. And those SCPs, they look very similar to what I'm going to show you in this particular AWS account today, but they apply to all users, including the root user. Okay, so that's how, if you want to or need to control that root user, you're going to need to get AWS Organizations up and running and create, at least a single member account within that organization, and then apply service control policies, SCPs, to it. Okay, so that's the root user. That's the first thing I wanted to talk about. I want to focus mostly on the main entities that you're going to create within IAM itself. And we're going to start with groups. By default, when you create a group or when you create your IAM account, it'll have no users, no groups. It may have some roles already set up in it, depending on exactly how you've deployed that account. We're going to start at the very top. Okay. A group is nothing more than a way to logically organize IAM users within your account. That's all it is. Okay? And we're just going to go ahead and we're going to create a group. And we're just going to call this, let's call it DBA admins. There's a lot of other things that we can do here, right? We can add users to the group. We can add permissions. We're not going to do any of that for the time being. We're just going to create an empty group. And then I'm going to create another group, and let's call this our developers, okay? And we'll do the same thing, create an empty group. So now we've got our DBA. I don't know why I called that administrators. Let's change that. We'll just call it DBAs. Okay. Simple. So now we've got our database folks and our development team. Okay. No users, no permissions assigned to them. So that's our first step. Remember, a group is really just a way to logically organize users. Let's talk a little bit more, or let's talk about users. The first thing we want to discuss about this is a user doesn't necessarily have to be a person. Right? In this case, we're going to create some fictional users, which we'll say are people. But you could have an IAM user that you use for an application. It doesn't necessarily have to be a person. The thing that I want to mention about users, and we're going to show you this as we build out a couple simple users, is that users provide permanent access to your AWS account, either through the management console, like what we're looking at today, or programmatically using, the Amazon CLI or an Amazon provided SDK. I still want to walk through everything, and we'll talk a little bit about roles in a minute. Generally, the way that we would suggest that you approach this is, wherever possible, start with a role first, because a role provides us with the ability to give temporary access to our AWS account, to a person, to an application, to a service, an AWS service. So you always want to try to start with a role first and then fall back to an IAM user if, for whatever reason, what you're trying to accomplish you can't do using a role. Okay. I'm going to go through the whole thing here, and we're going to create a couple users, a couple roles, just to simulate kind of how this would work. Okay. A user has permanent access. So let's go ahead and create a user, and let's call our first user Dave. Okay. The first decision that you're going to have to make is, how do you want Dave to access your AWS account? Okay. You have two options. You can provide access keys, which will allow Dave to interact programmatically with AWS, or you could provide Dave with a password. So then Dave could use that username and password to access the AWS environment through the management console. Or you could select both. Totally up to you. Here's my next kind of suggestion. Only provide access keys to members of your team who can justify that they are going to interact with the environment programmatically. Okay. How you decide that somebody justifies that access is completely up to you. But what I want you to avoid is just doing this, okay, for every user that you create. And the issue here is that access keys, they're made up of two components. I'm going to show you in a second. It's a secret key and an access key. And we use the access key along with the secret key as credentials to authenticate against IAM when we're interacting with the platform programmatically. The challenge with access keys is that there is no built-in functionality to force a user to rotate their access keys. So these are, again, examples of long-term credentials. We do a lot of audit work for customers, so reviewing what they have in their accounts. And what we do here is we, use things like the well-architected framework and best practices that we've developed over the years of building out solutions for customers. And routinely what we find is, first off, not least privilege IAM users in the account, like everybody's an administrator, let's say, and everybody has access keys, even though the vast majority of those access keys have never been used. And the ones that actually have been used are maybe multiple years old. So here's my first tip. Only provide an access key when it's absolutely required. It's less for us to have to manage in AWS and worry about those credentials leaking out of the environment, right? People make mistakes, things happen. So just don't hand them out if you don't need to. In my example today, I'm not going to follow my own advice, and I'm going to turn both of these options on just to show you what this looks like. Right? The other thing that I'll say about access keys is that it isn't a kind of assign an access key and forget about it. My other suggestion would be that you ensure that you have a process in place to routinely validate that a user, let's use Dave as our example here again, Dave justified that they needed those keys at the beginning. We're 6 months in, Dave's working away in these accounts. Is Dave actually using those access keys? So not only should you make the user justify the creation of an access key at the beginning, but you should have a process in place to routinely evaluate whether or not that access key is actually still required. What that process is, again, is up to you to decide. But in a lot of cases, we would put some automation in place that would look at the keys, and let's just make a number up and say every 45 days, we are going to disable every key that has not been used in the last 45 days. That's going to make, if that user suddenly tries to access the environment programmatically, it's not going to work. And it's at least going to initiate a conversation with that user. And then you might go a step farther and say, after we've disabled the keys 45 days later, if the key still hasn't been used in the next, let's make a number up again, 15 days, we're going to delete it permanently. Okay. So these are the types of kind of process and automation that I would suggest that you work into your environment to help you just manage it. So here's Dave. We're going to give Dave an access key and a password, and we're going to next assign permissions. Another thing that's really important to remember with IAM is that by default, IAM will deny all activity in your AWS account. Even just going through this process right now, if I was to give Dave their credentials, they wouldn't be able to do anything in this account because they have no permissions. Okay. Deny by default. Let's say Dave is one of our development team members. Okay. Permissions boundaries, we're not going to go into them today, but permissions boundaries act as a filter that allows us to control the maximum amount of permissions that could be applied to a particular IAM user in your account. Okay. So we won't worry about that in any more detail today. So we're going to add Dave to the developer group. Tagging is important. Tagging is a way to add metadata about resources within your account. So let's say our intent, if we go back to the example that I gave before, I want to notify Dave on day 43 that they haven't used their keys. And if they don't use their keys in the next couple of days, we're going to disable them. Well, how can I do that? One of the things that I might do is I might just put a key in here, and we'll just say Dave at Acme widgets, if I can spell, .xyz. Okay, so now I know how to communicate with Dave. And I might use this in a script that pulls out that information later on and then generates a notification out to Dave. Maybe Dave likes to spend their time in Slack, right? So I could do Slack contact. And I'm just thinking about this on the fly. So Dave's handle in Slack is Dave Developer. Now I know, if I can spell, developer. Now I know how to contact Dave via email and maybe generate a message off to Dave programmatically through Slack. So we'll say create, get a nice little review screen, and we're going to go ahead and create the user. The final step here is that we're going to, because we asked to create access keys for Dave, we get an access key ID and a secret access key, and I just asked it to generate a random password. So I can download this as a CSV. I could send an email to Dave telling him how to log in. And the thing that I want to point out here, we're not going to worry about this today in this demo. This is the only opportunity that you get to see the access key, the secret key, and the password. So you want to make sure you at least download these or have another mechanism to let Dave know how to log in. We're not going to worry about that today. We're going to say close. We've created our first user. Dave is a member of the developer group. Dave has never logged in, does not have a multi-factor authentication device associated with their account, and password and key is brand new. If Dave were to try to log in right now, or if Dave was to try to use the access keys that we assigned to their account, they wouldn't work. And that goes back to what I mentioned earlier on, that by default, this is a deny everything environment, right? Before we get into the permissions, let's create one more user. And we'll create Martha. And we're going to give Martha password-only access to the environment. And Martha is one of our DBAs. So we'll put them in that group. We'll also do set this up like we did before. I think I called it Slack contact. I already forget what I called it. Here's what you want to do is I'm doing this all through the management console, right? Click ops. In real life, we would suggest that you have all this done programmatically. How you do it programmatically, again, is a choice you would have to make. Our choice is CloudFormation to do that. You could use Terraform. You could create your own scripts with one of the Amazon-provided SDKs in a language that works for you. You could even just create simple shell scripts that are using the Amazon CLI. Completely up to you to decide what you want to do, okay? You want to do all this manually later. And let's say Martha's handle is just Martha. Say next, create. Okay. Again, we'll just ignore this. I'm going to create one more user just to show another concept. We're going to create Alice. Alice has access programmatically and through the management console. Right, Alice has gone through whatever our process is to justify getting those access keys to begin with, and then we're going to provide permissions. Users can be members of multiple groups. Okay, so let's say in this case, we want Alice to be able to do whatever the DBAs do and whatever the developers do. Okay. So put them in both the groups. And again, just for completeness, we'll do the same thing. And I don't think that's what I called that. I think it was just contact email, wasn't it? And then I switched this around just to make it challenging. And let's just say it's Alice. Now we have 3 users. Each of these users belongs to at least a single group. In Alice's case, they belong to 2 groups. Okay? None of these users have any access to the environment. Can't do anything. Okay? What we want to look at now are policies. Policies are JSON documents that provide access to AWS services, and then they allow us to define the actions that are allowed or denied to those services. As an example, if I just flip back and I look at this, let's keep it really simple. Let's say we have an EC2-based application that our developers are responsible for, and we're running an RDS database instance that sits behind that application. Really, we're talking here about 2 services, EC2 and RDS. When I'm thinking about the permission statements here, I'm going to allow access to RDS, and I'm going to allow access to EC2. Within each of those services, I want to get as fine-grained as possible, because the goal is to provide just enough access to do your job and nothing else. Right? I mentioned at the beginning, when we do audits for customers, this is one of the biggest challenges that we see. Right? Everybody is an administrator, or let's make it less dire. You have 10 users in an account, right? And 8 of them are administrators. Okay, that's pretty common. So what we're going to do today is just show you a really simple way through the management console or ClickOps to practice this idea of least privilege. And I use the word practice on purpose. This isn't something that you're just going to do one time and never have to look at again, right? People's roles change. The technology that you're using in this platform changes, right? So you're going to have to evaluate these policies on a regular basis. Again, I'm doing it through the management console. The goal really would be to do this programmatically so that it's easier to manage, and you can ensure that your security or in this case, your policies are enforced across, in my example here, a single account, or maybe you've got multiple accounts where you're dealing with IAM. So it's easier to manage it all centrally. We're going to go over to policies. And what you'll notice right away, there's a bunch of policies. There's close to 1,000 of them here. Now, some of these you'll notice are customer managed. So this is our little demo account, right? We're always standing things up. Looks like we could do a little bit of cleanup in here. These are probably a whole bunch of Lambda functions that were stood up for a training class and then deleted. So probably could do a little cleaning up here. The other thing I wanted to show you though is if you go up here, we can filter on type, and you'll notice that there are customer managed, there's AWS managed, and AWS managed by job function. Pretty self-explanatory, I think, what the difference is. AWS managed policies are created and maintained on our behalf by AWS. You can't edit them, but you can use them as a starting point for something that you're going to build. Okay? Generally, we would suggest that you create your own customer managed policies. Now, building a policy from scratch can sometimes be challenging. So even though I can't edit these, I could definitely just take this JSON and use it as the starting point for a customer managed policy that is more appropriate for whatever I'm trying to accomplish, right? So a lot of times, this is what we'll do. We'll just kind of cut and paste this into a CloudFormation template, which we're going to use as the starting point for our actual setup. Okay. Today, I'm going to create a customer managed policy though, and we're going to use this customer managed policy. We're going to create a really simple policy for our DBA. We're going to create a really simple policy for our development group. Okay. You can absolutely create these through JSON if you feel so inclined. What we would normally do is the visual editor is a fantastic way to get started. So I'm going to go through and we're going to create out a policy for our database administrator. And we're going to give this database administrator a few things that they can do. They can start a DB instance. They can start a DB cluster. Okay. They can stop a DB instance and a DB cluster. These are going to be really basic. They're just going to serve a point. Okay. That's all we're going to give this person the ability to do. Stop and start clusters. Okay. You'll notice that as we were selecting our options up here, we have now the ability to tie this to particular resources. And this is another really important part about building least privilege policies. Create specific policies. Amazon does a great job at kind of highlighting when you're maybe on the wrong path. Ultimately, though, it's up to your what am I trying to say here? Ultimately, it's up to you, there we go, to decide how you're going to deploy this. So you could just go over here and say any if you wanted. Okay. I wouldn't suggest that you do that. So what we can do is click add an ARN. An ARN is an Amazon resource name. It's a unique identifier for resources within your account. I'm going to say, what region are we in? I think I was using US East 1. And in this case, I'm going to allow this DBA to stop and start any RDS database cluster in this account in a particular region. Is it as locked down as it could be? No. If I actually knew my cluster names, I could put those in here, but this is still better than just saying anything, right? Okay, and we'll do the same for our DB down here. It'll look exactly the same. So there we go. The other interesting thing you can do are add request conditions. So this is going to be in addition to the policies that we've already set up. saying you can stop and start. But we could now say the source IP must be a particular, maybe a range. You want this person to be able only to, only stop and start, what did I say? Database instances when they're in the office or connected to the VPN. So you could put a range in there. You could also combine these together. Now, these are just showing you a couple common options for requests. There's all sorts of conditions that you can add here. Okay, so you'd have to look in the AWS documentation for that. Multi-factor authentication means that if I was to try to perform this action, it would prompt me for my token before continuing. I'm going to keep it simple today. We're just going to lock it down here to a particular cluster and a particular database, or I shouldn't say that, sorry, databases and clusters in this particular account in a particular region. Just like we did with our users, we can add some tags here. I'm not going to add tags to our policy here today. We'll click review and we have to give it a name. So we'll just call this our demo. Actually, we'll call it, what do I want to call this? Yeah, let's just do Acme Widgets DBA policy. We're just going to create it. So we're done. So I'm going to go up here and I'm going to filter by customer managed. There's our Acme widgets. If I drill into this, this is what the visual editor did for us, right? It created the JSON. Now, again, in a real situation, we may use the visual editor to help us define this based on customer requirements. And then what we're going to do is we're going to take this and we're going to put it into a CloudFormation template and deploy it programmatically. Okay? But for today, you can see how this works. And then I can go in and I can, summarize the policy here. I could edit the policy I want if I wanted, which is going to take me back to the visual editor. Or at that point, maybe I'm going to make some changes in the JSON window. Again, up to you. The other thing I wanted to show, just a couple other tabs, where is this policy associated? In this case, it's attached to nothing. Okay. Any tags? The other important thing about a customer managed policy is it provides us with versioning, and we can keep up to 5 versions of a policy. This is really handy. Let's say you put this in place and the DBA is off working away, and they come back and say, routinely we have to perform this other action against the databases, but we don't have access to it. Could you add it to our permissions? What you could then do is go in and modify this to give them access to that new action, and you would have a new version. In the event that you made a mistake and you want to quickly revert back to a working version of that template, you could do it right from here. Okay. You can keep up to 5. And the Access Advisor, we're not going to see much in here today. Remember I mentioned that one of the important things is that, okay, great, you've done the practice of least privilege and you've created something that is limiting a person to a particular job function. But you still need to routinely evaluate these. So with Access Advisor, you can see it's showing us the permissions that have been granted to the user and when they were last accessed. You can use this, like if you get a requirement from the DBA that says, we need stop, start, and terminate. Okay. Well, what if they never use this stop action for some reason? So you could go in here, you could look at that and understand that they've never used it and then remove it to really keep that idea of least privilege. Okay. We're going to go back over here. We're going to go to policy usage. And now we're going to attach this not to a particular user, but a particular group. And we created our DBA policy, so we'll attach it to the DBA group. And now we're going to do the same thing again, and we're going to create another policy. And in this case, we're going to EC2. We're going to do the same thing. Start instance, stop instance, and that's it. Okay. Not a very effective policy, maybe for a development team, but it's going to illustrate the point today. Just like we did before, we want to make sure this is specific. So we're going to go in and we're going to add an ARN. like we did before, we're going to say allow them to stop and start instances in a particular account, in a particular region, but any instance ID. I'm going to come back to this in a second. And then we'll do the same thing for license config. Okay. There we go. Now, I mentioned request conditions down here. The other thing that you could do is you can actually use tags as part of your condition statement. I could go a step further with this, and let's say in this account, it's a shared environment account. So I have production and development resources running in this particular account. Normally, we would try not to do that for a bunch of reasons, but let's just say we do. And then you have, we'll use an example of, let's say, junior developers. Actually, no, let's do this. It's easier. Junior developers and senior developers. And you want to allow the junior developers to stop and start any EC2 instance in this account if it's a development machine. And then you want to allow the senior members to be able to stop and start anything. The way that you could do that is by providing a request condition here that says the members of the junior development group can stop and start instances, but only if those instances have an environment tag that's equal to development. Okay, conditions can get really powerful. So it's a fantastic way just to add an additional layer of security to the policies that you're creating. Okay, we'll keep it simple today, and we'll say next. We won't worry about tags here, and we'll go. I already forget what we called the other one. I think it started with Acme widgets, and we'll just say allow developers to stop. Right. At least that way we can remember what it is later on, and we'll create that policy. And then we can go and find our developer policy. I called this policy. Again, naming standards are important. Can't remember what I did 2 minutes before I typed it. So we'll say attach, and we're going to do the same thing. We're going to attach it to a group. And I'm doing this for a reason. One of the other things that we often see people do is assign permissions directly to users. And that might make sense in this particular case because we only have 3 users. The challenge, though, is as the number of users grow, the management effort within this account becomes very, very challenging. And with the more management, the more potential changes, the more opportunity there are for mistakes to be made, right? That stop somebody from doing their job, or even worse, open something up for a security issue that you weren't aware of. So by grouping things or grouping users logically and then assigning permissions at the group level, it does simplify the management of permissions over the long term. Okay? I'm going to talk a little bit more about how to simplify IAM in general here in a second, but that's how you're going to do this. So now you can see that Alice is able to stop and start EC2 instances, stop and start databases. Dave can only stop and start EC2 instances. Martha can only stop and start database instances. Okay. So that's all set up, right? We're practicing that idea of least privilege and limiting everybody to just what they need to do. I mentioned when we got started that the way that we would suggest that you start is avoid creating users in the first place, if at all possible, and use roles instead. I'm not going to kind of go into cross-account access and identity federation and all that kind of stuff today, but what I am going to show you is a way that we could use a role to provide our users, Alice, Dave, and Martha, with the ability to temporarily elevate their privileges to do something that they normally can't do. The analogy that I like to use with this is if you've ever worked in a Linux environment, right? You log in as an unprivileged user, and then you run a sudo command to elevate your privileges to perform a particular action, and then you go back to your regular user. You can use a role the same way. So we're going to create a role, okay? And this role we're going to allow. If I go back here, we're going to allow Alice and Dave to assume this role, okay? Because they're in our developer groups. And what that'll allow both Alice and Dave to do is terminate EC2 instances. Then we're going to create another role, and we're going to assign that role to Alice and Martha, which is going to allow those two users to temporarily elevate their privileges to terminate a database instance. Okay, so let's do that. We're going to create a role. And right away, you have to sort of decide how you're going to do this. Amazon's done a good job at setting up a graphical way to do this. So you just kind of walk through the steps. Other AWS services can assume roles. Resources in a separate AWS account can assume a role. And then we've got this federation piece here, either with web identity providers or SAML providers, or you can create your custom role. We're actually going to do a custom role here. And what we're going to do is we're going to tie this particular role to a particular user within this account. Okay. And I actually need to, before we do this, that's fine. I need to just cut and paste a few things here. Bear with me 1 second. I'm just getting the ARNs for the 3 users we've created. Because I'm going to use the identifiers, the ARNs, to determine who can assume each of the roles. Okay, so that's taken care of. The other thing that I need to do here, I should have had a little cheat sheet for this, but I didn't make one. So just bear with me 1 second. I can never remember the format of the little principal section. See if I can quickly find an answer for this. So I'm going to go over and say create a role. We're going to go back to a custom role or a custom trust policy. A role is made up of 2 pieces. The first thing is the trust policy. Think of this as the authentication piece. It is going to allow us to control who, in our case, like Alice and Dave, or what, maybe another service or something that's been federated by a directory service outside of our AWS account, who or what can assume this role. That's what we're doing here. Okay, and I just have to get the format here. Okay, perfect. And then we're going to put in here the 2 ARNs. I'm going to open up another tab because I already forget the user breakdown that we created for the groups. Let's do it this way. So we need, let's create the developer role first. So Alice and Dave, we need to assume this role. Okay, so let me grab the ARN for Alice. Okay. And then we also want to add the ARN for Dave. Okay, and that should do the trick. What this is saying is allow Alice, identified by this ARN, and Dave, identified by this ARN, to run the STS assume role. Okay, so what that is a security token service, and that's the actual action. Okay, so we'll say next. And now we have to decide the permissions policies. And I actually got ahead of myself a little bit. We're going to create a new policy, and we're going to call this, what did I do this for? I think this was the developers, right? We're going to say EC2. And we're going to only provide one action to simulate this. So if you want to terminate an EC2 instance, basically delete an EC2 instance, you can't do that with your regular credentials. You have to assume a role, in this case, temporarily elevate your privileges to be able to run a terminate instances API call. And just like we did before, we're going to lock this down a little bit. So we're going to say, again, only this particular region, but any instance within this account. Okay. You could put, actually what we'll do here is we'll just show this. When you run your terminate instances API call, you have to provide a multi-factor authentication device with it. Okay, so a token. We'll say next. We'll review this, and we'll call this I know I've messed my naming standards up. Developer, and we'll call it right? The policy. That's done now. And then we can go back here and we can look again for customer managed. And there's our privileged policy, and we'll associate that to the role. Right? And we'll just call this developer admin role. The name kind of explains it, so I won't worry about a description here. Permissions are already set up, and then we'll create the role. Okay. So what happens now is Alice could log in with their regular account, and in Alice's case, stop and start database instances, stop and start EC2 instances. If they needed to, for whatever reason, terminate an EC2 instance, Alice could then assume that role that we just created, which would allow them to run the terminate instances API call. Okay. If I just quickly search for the role, I want to show you what we created. I already forget what it was called. I thought we called it Acme Widgets. Isn't that amazing? Maybe it was just, there we go, developer. Note to self, next time I do this, I'm going to have all my naming standards laid out first. I just want to show you what we've done here. The first part is the trust policy. This governs what or who can assume the role. In this case, we've tied it to two particular users in this specific AWS account. And then we have to assign the permissions, okay, to that. You'll also notice we still have the ability to limit a permissions boundary on this particular role. Okay. If we have time, maybe I'll show you that. Okay. Tags, access advisor, just like we saw in our regular permissions. And you can also revoke all of the active sessions that have assumed this role by clicking on this button, and away it goes. Okay. So we won't worry about that today. The next thing I want to do is I want to create a new role for our other users. And in this case, I want to put Alice in this role as well. And I think it was Martha is our other DBA. So now Alice and Martha can assume this role. And this is important because even if Dave had the information that they needed to assume this role, without them being defined in the trust policy, they'll get an access denied when they try to assume the role, because we're not allowing them to run this assume role API call against this particular role. So we'll say next, and then we're going to create a policy, and we'll call it, we won't worry about the cluster part of this. Is it delete? I forget what it is now. Yeah, there it is. Delete. Oh, down here. Okay. And then we can go up here and add the ARNs again. Tag it if we needed to, and then we'll call this DBA. We say it's amazing how quickly you forget privileges, right? Elevated privileges, and we'll just say create. Naming standards are important. Think of your naming standards ahead of time, and again, we would do all this programmatically, so I don't have to remember it all. Okay, I called it Acme Widgets Developer Privilege the first time around. This one I just called DBA, so I'm messing this up, but what we can do is go over here and say DBA, search for that, right, and then associate it. And this we will call them. Well, you know what I should have done? I should have done this. So developer admin role. We'll call this DBA admin role. So now what we've got is we've got 3 users, members of different groups to control their privileges, and we've given them limited amounts of privileges, stopping and starting EC2 instances or database instances. Then we've created a role, one for our DBAs, one for our developers, tied that role to a specific user or a number of users using their ARNs, their Amazon resource names, and allowed them, when they assume that role, to elevate their privileges temporarily in order to perform what we'll call higher value tasks, right? We want them to be able to terminate an EC2 instance or terminate a database instance. So that's a little bit about users, groups, roles, and policies. The next thing I want to talk about, we won't go into really too much detail here, but I've already mentioned that you want to avoid, wherever possible, creating and maintaining all of this. And the way that you do this is through federation. If you've got a directory service that already exists outside of AWS, what you can do is you can establish a relationship between IAM in your AWS account and that external IDP. Okay, and then once that trust policy is established, what we could do is create roles so that we're not creating and maintaining users in both places. Okay? That means that I authenticate with my existing IDP, and then I'm able to either get management console access or access this environment programmatically by assuming a role in AWS, which would avoid, let's say Alice, Dave, and Martha all exist in our corporate directory. Instead of now having to manage them here and on-prem, you could do that federation and just use roles to give these users the access that they need without having to create and maintain things here. Okay. No permanent credentials because you're using roles to give temporary access to the environment. That is the best way to do it. I know in some cases, though, some of the smaller customers that we work with, they don't have those types of directories for whatever reason, right? There's lots of reasons why, and we end up creating and maintaining users like this. The other thing I just want to stress here is, everything through ClickOps, there's nothing wrong with using the management console. I'm in the management console every day figuring out this type of stuff, but when I'm ready to deploy it, we're building all of this into CloudFormation templates. Okay. So that's users, groups, roles, policies, IDPs. The other thing that I wanted to show, really simple little setting that's really important, especially if you've got users within your IAM account, within your AWS account, is set a password policy. Okay. So you can do that right here. We've got a simple one set up, even though we don't normally have users in this account. This is going to force the use of what we'll call strong passwords, right? Certain number of characters, you know the drill here, changing it every certain amount of time. The thing to keep in mind with this is this will force a user to change their password for the management console. It does not enforce rotation of access keys. Okay. Now, speaking of access keys, let's go back to Alice here. We'll use Alice as our example. Now we know the permissions that are associated to Alice through group membership. See this right here? The other thing that you can do is you can create what's called an inline policy. An inline policy is embedded directly into the user. So in this case, Alice. If we were to create an inline policy and embed it into Alice's account, if we are ever to delete Alice's IAM account, any inline policy that we associated with their account also goes. Generally, we would say try to use managed policies through group membership rather than inline policies. But if you do need to maintain some type of strict one-on-one relationship, then an inline policy might make sense. Okay? The other thing to keep in mind with an inline policy is there's no versioning. So if you make a mistake in that inline policy, you're going to have to figure out what you did wrong. You can't just roll back. Okay? We can see that Alice is a member of 2 groups. We did tag Alice with some information. Maybe we can use this for automation later on. Here are Alice's security credentials. Alice has a console password. They don't have an MFA device. Okay. Here are the access keys. And this is what I was saying. This is the secret, the access key, but we can't see the secret access key. Every user can have up to 2 access keys. You can make them active or inactive. Okay. And then if you needed some other credentials, you've got other credentials down here. And here's the Access Advisor. So we can look at individual user level here as well. What has Alice actually used over the last number of days based on the permissions that have been assigned to that account. A couple other things I just wanted to point out down here. Access reports, really important. There's something called the IAM Access Analyzer. The IAM Access Analyzer is a great way to understand what has access to this account from outside what Amazon calls a zone of trust. I already set this up because we run this in all of our accounts. In the demo account, I have the zone of trust set to the current account. What this means is if there are access policies within this account that provide a person or something access outside of this account, we're going to get what they call a finding right here. Okay. So let's say we create a policy that allows somebody to assume a role from another AWS account. By default, we would see that in this screen because it's allowing somebody or something access to this account from outside of its zone of trust. Okay. You'll notice that I don't have anything here. That's because everything's been archived. And one of the things that you can do is create archive rules. So you don't have to go in here and manage each individual finding. Instead, we can create archive rules that help us manage those access policies automatically. I won't go into the details of these, but I know that I've got Cloud Custodian. I know that I have access from what we call our support account. And those are legitimate ways that we want to allow people or applications to access our demo account. So I've created a simple filter here to filter those out. Okay. If something were to be created that doesn't fulfill one of these archive rules, I would show it here. Okay. Really important thing just to quickly turn on so you get an idea of who or what has access to your AWS account. Okay, from outside the zone of trust. You can also generate what's called a credential report. This is basically a listing of all of the IAM entities within your account and a summary of their current settings, access, last time they accessed, last time they changed their passwords, things like that. So this is also something that's really important. You would want to maybe generate this report on a regular basis and go through it. Okay. You've got organization activity here. So this is part of the AWS organization service. We're not in our management account, so we can't actually see this. And then I mentioned service control policies at the very beginning. And again, we're not in our management account, so we can't see those. Okay. So that is at a very high level, the identity and access management service and kind of how you might want to consider sort of getting started managing the entities and the permissions within your IAM account. Okay. Remember though, couple key takeaways. Wherever possible, start with a role first to avoid having to create and maintain credentials in multiple places. That goes for users, that goes for applications, that goes for other AWS services. We want to avoid those access keys wherever possible because access keys tend to lead to potential security issues or just bad management practices over the long term. So that's the first thing. Start with a role first. Okay. And also remember that you want to do much of this as best as you can programmatically and practice least privilege. Don't make everybody an administrator. I know the samples that we did today were very, very basic. Remember that you can tie those down much tighter than we did here, but I wanted to make sure that I could show you a simple way to use the visual tools to start in a good position, at least, by not just saying allow a user or a group of users to do anything they want across any service within the AWS account. Okay? Role first, automation, least privilege. 3 main takeaways. So thanks for joining us today. Episode 1 is now in the books, and we'll be back in a month. I think I'm going to do these every month to start, and we'll have another topic to discuss. So thanks very much for joining me today, folks. Bye-bye, everybody.